Hi everybody. So in this video, I'm going to show you how to approximate a binomial distribution using a normal distribution. So in this example, we're told that the random variable x is distributed binomially with 90 trials and a probability of success of 0.52. We've been asked to use a normal distribution to find the probability of x being less than 48. So if we define our normal distribution, we'll say that y is distributed normally with a mean of mu and a variance of sigma squared. But now we need to work out this mu and this variance from this binomial distribution. And we're given in the Edexcel formula booklet that mu, the average of a binomial distribution, is n times p, or the number of trials multiplied by the probability of success. And this gives us 46.8. And the variance of x is np multiplied by 1 minus p. So if we multiply this by 0.48, we get 22.464. I'm going to round this to 2 decimal places, so 22.46. So now for our normal distribution, we know that y is distributed normally with a mean of 46.8 and a variance of 22.46. Okay? So for part A, find the probability of x being less than 48. But we need to remember that this 48 is a discrete value because it's come from the binomial model. And the normal distribution uses a continuous scale. So we need to apply continuity correction so we can plot this discrete value on our normal distribution curve. We know the mean will be at 46.8, which I'll show here. And because this has to be less than 48, it means the greatest value that x could possibly be is 47. So to account for this, we need to work out the lower bound of this 48 when it's rounded to the nearest integer. So what we're looking for then is when y is equal to 47.5. So the probability of x being less than 48 will be approximately the probability of y being less than 47.5. It can't be equal to 47.5 because if it was, it would become 48 and it has to be less than that. So now we can use the normal CD function on our calculators. If we go to menu, we want option 7 for distribution, option 2 for normal CD. The lower value has to be 3 standard deviations below the mean, or any value less than that, so I'm going to leave mine at 0. The upper value, we know is 47.5. We know the standard deviation is the square root of variance, so the square root of 22.46. And we know mu is the mean, which is 46.8. So we can work this out, and we get approximately 0.559. Okay, for part B, find the probability of x being greater than or equal to 65. Well, this means that the lowest it can possibly be is 65. It cannot be 64. So when we apply continuity correction, this will be approximately the same as the probability of y being greater than or equal to 64.5. Any less than this and it becomes 64, which does not obey this statement. So if I show this on our normal distribution curve, we'll use the normal CD to work out the probability of this area. So we'll go back to normal CD. This time we'll enter the lower as 64.5. The upper has to be 3 standard deviations or more above the mean, so I'll enter 1000 or 10,000, and sigma and mu remain the same. So we can equal this, and we get approximately 9.39 times 10 to the minus 5. And then for part C, the probability of x being equal to 43. So to apply continuity correction to this, we know it can't be 44 and it can't be 42, but it can be all the values in between. So this will be approximately the probability of y being less than 43.5, so it doesn't become 44, but being greater than or equal 42.5, so it doesn't become 42. And I can shade this region on our normal distribution curve. So entering it into our calculators, we'll have a lower as 42.5, the upper as 43.5, and sigma and mu the same, and this will be approximately 0.061. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.